to determine if the table of values represents a function, we must, just like always, examine the inputs. We don't really care about the outputs so much as we care about the inputs. If an input repeats, and I want you to read this carefully, because I go a little deeper than the book does. If an input repeats and is paired with a different output, it's not a function. Now, in a table, the first thing we always look for is to see if an input, an x value, repeats. If it does, that's a big red flag that it may not be a function. But once you identify repeating inputs, you always have to check the output. Is it matched up with the exact same output? Because if it is, that's fine. If it's matched up with different outputs, that is not a function. So we're going to look at this first table. We look at all the inputs. It's very simple. Pretend these don't even exist. Look at the inputs. Do any of these inputs repeat? Yes or no?
No.
No. Then you don't have to do anything else. None of them repeat. That is a function. It does represent a function. It's just that simple. Look at my inputs. None of them repeat. Boom. That's a function. It's just that simple. Input 5, 10, 15, 20, 25. None of them repeat. That's a function. How do I know? Because each of these inputs is only paired with one output. Told you you'd hear it a lot. Now we look at this one. Once again, you ignore this. Just look at the inputs. Do any of these inputs repeat? Yes or no? Yes. Which one? One. This repeats. So once you realize that an input's repeating, you have to look at the outputs. Is this input paired with different outputs? Yes. Which means that it's not paired with only one output, it's paired with multiple outputs. So this does not represent a function. It's just that simple. You look at the inputs. It repeats. It's paired with 4, it's paired with 10. That doesn't work because if this was a mapping diagram, it would look like this. 1, 4, 10. And as we know, that is not a function. What's up?
So what if the one, say 110 is paired, and then what if there's another 110?
If this was 110, is that a function, yes or no? Yes, because although the inputs repeat, it's paired with the exact same output, right? So if you were to write this as a mapping diagram, let's look. Let's see what it would look like. 1 and 10. That's a 10, by the way, horribly drawn. So that would be a function. Inputs can repeat if they're paired with the same output. But in this table, the input repeated, it was paired with a different output, and if you always want to double check it, make it a mapping diagram. Okay, I have 1. I don't have to write the 1 more than once, and it's paired with 4 and 10. So I have 2 different lines coming from this input to this output. That is not a function. It's not. Right. Okay. All right, let's try a couple of these. So again, questions on this so far? Pretty simple. Look at the inputs. Is it paired with different outputs? All right, let's go to my main homie, Adrian Nico. Is it a function? Yes or no?
Yes.
Yes. Look at the inputs. None of these repeat. There's nothing else I have to do. This is a function. Inputs do not repeat. Make sure you're writing this down. At the very least, write a function. If you want to write inputs do not repeat, that might be a good little thing to jog your memory when you come back around. Zozo! Is this a function?
No.
It's not. Why? What input repeats? 8. 8 repeats. And then the question is, okay, well it repeats, okay. Is it paired with different outputs? Yes, it is. If you were to write this as a mapping diagram, you would write 8, you would write 21, 34, and as you can see, that is not a function. Not a function. So this would be, let me erase all this here. Not a function. Inputs repeatify. That's a real word made up by me. All right, Katrine. Is that a function, yes or no?
Yes.
Yes, it is a function. We look at the inputs. Do we care that these outputs repeat?
No.
No, we don't care. We don't look at the outputs. The only time we look at the outputs is if we see repeating inputs. These inputs, boom, 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 do not repeat. That's a function, baby. All day, every day. All right, all right. Boom, boom. It's made easy because by now the hardest part of this module is just finding the slope and the y-intercept. As long as you got that, functions aren't hard. If you still don't have that, you need to come see me for help to practice it because that right there, knowing how to find the slope and the y-intercept and write that equation, also writing a function, that right there can make the difference between you passing or failing the FSA. Just that one part because of how much you see it over and over and over and over again on your FSA. Writing equations from tables, from graphs, from situations, writing functions, all the same thing. It makes up like 40% of your FSA. That makes, right there, just knowing that, you can almost guarantee yourself, if you know it front to back, you can guarantee yourself a pass on the FSA. Just that one thing front to back. No, I'm talking about knowing how to find slope, y-intercept, write an equation, function. There's so much wrapped around that. That's pretty much, that's it. I mean, you want to know the other stuff for sure. But like I said, especially for those of you like a 3. No, I don't get 3s. It's for peasants. I get a 5. Anything other than a 5, my parents would have told me I could see in the backyard.
Oh my God.